Welcome to another episode of With Easy. Today we're going to walk through the last figure that have been discussed in this specific Jupyter notebook in the GitHub repo called DV4C. And this one is a stacked line plot. To view the original line plot, you can actually find it in the same directory, and it will be this stacked plot example.png file. And the raw data will be this CSV file named multi-sample deconvoluted mass spec data. And if you read more in details about this Jupyter notebook, well, it's mentioned that the samples plotted here are from that multi-sample CSV file, but focus on only one of the conditions. There are 8 samples in total. There's also a 20x zoom in the signal in the stack plot. So we'll walk through how we can generate a stack plot first, and then we'll focus on how we can properly zoom in here. So as always, we'll start by creating a new Jupyter notebook. If you are confused by some of the basic operations I'm doing here, make sure you check out the introductory or the Python basics video that we shot probably like almost a month ago. So without further ado, let us jump in. And let's rename this mass spec deconvoluted stacked line plot. All right. So we have already downloaded the raw data from the GitHub repo, and if you're interested, you can actually just click on this in this web UI, and you can click on the download here. This will trigger a download into a folder that you select. But in our case, given that we have already downloaded this, we will make sure that we copy the path name into our Jupyter notebook. And we have walked through the contents about how we can visualize or examine a CSV file to understand the data structure in our last video. So if you're interested in that, make sure to check it out. But for now, I'll just directly basically visualize the data for all of us. So okay, as we can tell, we have 4 columns in the data frame. We have the mass, the counts, a series of vowels, and a series of conditions. So as we kind of discussed, there are 2 conditions in this data frame, and we'll focus on condition B in this case. And we can also see that in condition B, there are 8 different samples with the wall number of number 8 to number 15. So this gives us an idea about how to best describe this scenario to ChatGPT. And to start, we will try to use the screenshot function in ChatGPT. And let's see what we can do here. So I have a pandas data frame with 4 columns. I want to focus on the samples with condition equal to B, and there should be 8 of them as identified by different values in the val column. Now I want to plot each val sample, or actually the method data of each val sample as a line and stack the line on top of each other as shown in the screenshot. Can you generate the codes for me? Given that my data frame has a half name of copy this in as well. Let's see. I don't think this code will work because I already spot some error here, but let's see what we got. Yeah, exactly. So there's a key error of label. And if we, oh, let me just copy. All right, so if you read through what's got explained here, it's basically saying that we don't have a column named label in our data frame. So we shouldn't use that. And if we replace the code here with the new one, we can see that it already worked, but it looks quite different than what we got here. I think the key part is that even though the ChatGPT will label the XX as relatively a mess, we know that this is actually the absolute mess plotted here. So, and something else is that this is actually plotted in 8 separate subplots, um, instead of having like one plot. So, if we refine our request, and we will revisit the relative mess later, but let's focus on how to combine the lines into one plot. All right, let's see what this got us. So now we can tell that actually it did plot out 8 samples here, but they are all overlap on each other. So it looks like ChatGPT lost the context a little bit already from our original question where we say that, I think right here, I'm pretty much gonna say that, yeah, I want to stack the line on top of each other, but maybe that's ambiguous, because, but we definitely don't want to overlay all the lines. Let's say I have all 8 lines in the same plot, but they are overlapping on each other. All right. So now ChatGPT basically suggests that we do a offset vertically for each line. So let's see how that looks like. So looks like we successfully offset each line, but now There's still a significant amount of overlapping around the highest peak, or the actually we know that's the full-length product. We can consider address that now, or because we're gonna, like, if we read back to our Jupyter notebook, we're gonna do a 20-fold zoom for the counts or for the signal of the mass spectrometry. Maybe we can save that for later. So let's see. What if I want to zoom in on my count? Let's see whether ChatGPT can help here. Let's see. If we don't really understand Python, let's just describe what we saw here. Hmm. I don't think this will work either. Yeah. So it looks like this is where ChatGPT struggled, is to zoom in individual traits and stack them together. Maybe we need to walk him through the issue a little bit. Can you generate codes to do for each sample? I guess if we, let's think through this, right? So if we are writing the code, or a pseudocode even just for this to implement this, it will be, we need to select for each sample. All we actually need to do is find the difference between the minimum signal and the maximum signal. Since we're zooming in 20-fold, basically saying that we only want to look like, say, 5% of that difference. And we want to select signal that are between the minimum counts and minimum counts plus that zoom in range that we want, and only plot that subset of data. So now we need to describe this in English and let ChatGPT translate it into codes. So find for each sample, find counts, calculate the difference max mean, calculate the zoom in range as max 20, select signals falling into the range of mean and mean plus and only plot the signals selected in step 4. All right. Now, if we select this, do this, this looks a lot better, and it's actually a lot similar to what we saw here. It's just the offset here now is much larger compared to the after filtering signal. That's why our signal is so small. We can either manually adjust the offset, or we can ask ChatGPT to adjust it for us. So this works. I noticed that the offset is now too large for my post in signals. Can you dynamically select the proper offset value for me based on the date? All right, let's do this. Now this is a lot better, and it's actually a lot similar to what we have seen here. The only two issues here are probably we're not really plotting the relative mass on the x-axis, and we need to set a range based on the relative mass. So this will be the last thing we need ChatGPT to fix for us. So in the code above, you are plotting the absolute mass of relative mass. If I believe that the highest signal prior to zoom should be set as the 0 point for relative mass, can you help me to generate relative mass for each sample and then plot it as the x-axis? All right. if we do this, and now this is really the relative mass. So this is very smooth so far. We then just need to set a range to maybe from minus 2000 to, I think this looked like 200. Great. Can I set my x-axis to range of minus 2000 to 200? All right. Now if we plot this, this looks great and is pretty much exactly the same as we see here, except that the legend obviously is different. This is colored by sample. Given that we don't have the sequence of the DA plotted here, so it will be a little bit harder for us to figure out the species of the truncated base, which is what is colored here. But the other issue is that the legend is obviously blocking some of our samples. So we can then ask ChatGPT to help us with that. Can you move legend outside of the plotting area so it doesn't block the view of some traces? Oh, then we need to start a new chat because we run off the GPT-4.0. I see. It doesn't remember our previous chat, so let's grab that from here. Can you do that in the URL with the following code? All right, this and that's it, right? So we successfully reproduced the plot here, and some of you might notice that in this original plot, it looks like the around the full-length product region, when we cut off at the 20x zoom in, this data point seems to be disconnected, while in our data points, these two data points are joined by a directed line. I think that's probably the difference between the matplotlib and when we use the Seaborn. I believe that's what we used to generate this plot originally. And feel free to try it on your own. Can you use ChatGPT to help you solve that issue? Can you not let the matplotlib to automatically connect the dots when there are missing data? And with that, I would like to conclude our video for today. And if you really enjoyed the discussion of how to generate insightful plots, just with the help of ChatGPT, without prerequisition of extensive coding knowledge, just as what we did today, make sure you give a thumb up to the video. That would be greatly appreciated. And also subscribe to my channel. I try to update it or provide new videos every 1 to 2 weeks. And with that, enjoy the rest of your day, and I'll see you in the next video.